Hello students, in this video we will find center of gravity, or it is called as centroid also, of the region bounded by z is equal to x square plus y square, z is equal to 0, x is equal to minus a, x is equal to a, y is equal to minus a, and y is equal to a. So now here this z is equal to x square plus y square represents a paraboloid which is about z axis. Z is equal to 0 represents xy plane, x is equal to minus a represents plane which is parallel to yz plane and passes through point minus a comma 0 comma 0. X is equal to a represents plane which is parallel to yz plane which passes through point a comma 0 comma 0. Y is equal to minus a represents plane which is parallel to xz plane and passes through point 0 minus a 0, and y is equal to a, this also represents a plane which is parallel to xz plane and passes through the point 0 comma a comma 0. So here the region is bounded by these surfaces. Alright, so let us see how this z is equal to x square plus y square, the paraboloid, looks. So this is z is equal to x square plus y square. Okay, our region is bounded by this paraboloid and these 5 planes. So you can see here, this is our region. See here, our region is outside this paraboloid, outside this surface of the paraboloid, and it is inside these 5 planes. This is first plane, which is x is equal to minus a. The next blue plane is x is equal to a. Then this left side green plane is y is equal to minus a, and this right side green plane is y is equal to a, and here this horizontal plane here, that is z is equal to 0. So our region is it is inside this open box, these 5 planes, z is equal to 0, x is equal to minus a, x is equal to plus a, y is equal to minus a, and y is equal to a. These 5 planes forms open box, open from top. Okay, so the region is inside this open box and it is outside this paraboloid, z is equal to x square plus y square. So it is outside this red surface. Now we'll find limits. So if you take one vertical pillar in that region, you can see that this pillar will move. So we have to move this pillar in this region so that it will cover whole region. You can see x will vary from minus a, that is from this blue plane, to this front blue plane. So limits of x are from minus a to plus a. Now horizontally this will vary from the left side blue plane to right side blue plane. So limits of y are from minus a to plus a. Now to find limits of z, we have to see how the bottom of that pillar varies. You can see here the bottom of the pillar varies according to this plane, z is equal to 0. So lower limit will be z, lower limit of z will be 0, and the most important thing is top of the pillar. You can see here the top of the pillar varies according to the surface of the paraboloid. So therefore upper limit of z will be x square plus y square. So these are the limits of z. Z will vary from 0 to x square plus y square. Now the one more thing is, as the region is symmetric about z axis, the center of gravity lies on z axis, and therefore x bar and y bar both are 0. So we have to find z bar. So this is a formula for z bar, integration of z dv upon integration of dv. So let us calculate numerator and denominator separately. So numerator is integration of z dv. So we have to integrate this z dz dy dx within the limits. X varies from minus a to plus a, y varies from minus a to plus a, and z varies from 0 to x square plus y square. So this is a simple integration. So you take this as exercise, you can show that this is equal to 56 upon 45 a raised to 6. So this is a numerator. Now we will calculate denominator. So we have to integrate 1 within these limits, same limits. So this is also simple integration, and when you solve it, you will get denominator as 8 by 3 a raised to 4, and therefore z bar is 7 by 15 a square. So and already we knew that x bar and y bar are 0, so therefore center of gravity will be at this point 0 comma 0 comma 7 by 15 a square. So this is how we can find center of gravity for a three-dimensional object. Thank you.